Predictive maintenance for machines. Predictive maintenance. 1. Uses digital twins to forecast maintenance requirements and reduce unplanned downtime. Digital twin. 1. A virtual representation of a physical asset, process, or system. 2. Provides real-time insights, allows for simulations, and leverages predictive analytics to forecast maintenance needs. Benefits of digital twins for predictive maintenance. 1. Enhanced asset visibility. Offers a comprehensive understanding of asset condition and performance. 2. Improved maintenance planning. Helps anticipate maintenance needs and schedule repairs proactively. 3. Reduced downtime. Minimizes unexpected equipment failures and production disruptions. 4. Cost savings. Reduces maintenance costs by preventing unnecessary repairs and optimizing maintenance intervals. Real-time dynamics and functionality mirroring. 1. Captures real-time data from sensors to replicate actual operating conditions. 2. Data acquisition. Sensors collect data on asset performance. 3. Data analysis. Data is analyzed to identify patterns and trends. 4. Virtual simulation simulates asset behavior based on analyzed data. Forecasting maintenance requirements. 1. Analyzes historical and real-time data to predict maintenance needs. 2. Historical data provides insights into past maintenance events. 3. Real-time data tracks current performance and condition. 4. Predictive models forecasts future maintenance needs, reducing unplanned downtime. 1. Proactive maintenance minimizes risk of unexpected failures. 2. Optimized repair schedules ensures timely repairs, reducing downtime. 3. Improved asset availability maximizes production uptime and efficiency, building an analytics platform. 1. Data integration connecting data sources from sensors and other systems. 2. Data processing cleaning, transforming, and preparing data for analysis. 3. Data visualization presenting insights in a clear and actionable way. 4. Model development building predictive models to forecast maintenance needs. Predictive algorithms and machine learning. 1. Regression analysis identifies relationships between variables. 2. Neural networks learns complex patterns to make accurate predictions. 3. Time series analysis analyzes data over time to predict future behavior. Optimizing maintenance schedules. 1. Predictive maintenance schedules maintenance based on predicted needs. 2. Condition-based maintenance triggers maintenance based on real-time data. Improving overall equipment effectiveness, OEE. 1. Increased uptime reduces downtime by preventing unexpected failures. 2. Improved quality ensures consistent product quality. 3. Reduced maintenance costs optimizes intervals and minimizes unnecessary repairs. This approach helps achieve significant improvements in machine uptime, operational efficiency, and overall performance. By leveraging digital twins and advanced analytics, companies can enhance their maintenance strategies, leading to a competitive advantage. 4.0